Okay, we're going to look at number 30 from the 2015 June Common Core Geometry exam. It says after a reflection over a line, triangle A prime, B prime, C prime is the image of triangle ABC. Explain why triangle ABC is congruent to triangle A prime, B prime, C prime. So we have a reflection. And if you remember, a reflection is a rigid motion transformation, which means the shape stays the same. But you have to figure out a way, or you have to explain it. So that's something a lot of students have a lot of trouble with, is explaining their thought process. So simply, what you can simply put is a reflection is a rigid motion transformation, which means that distance is preserved from the pre-image to the image. If you remember in our proving triangles congruent, one of the ways we could was by side, 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 or SSS we called it. If you could prove the two triangles had the same side lengths, then they have to be congruent. Well, if distance is preserved, that means the side lengths remain the same and you have something being congruent. So that would be enough right there. Also, you'd want to know that the angle measures also remain the same. So, just to know that the side lengths and interior angle measures, also exterior angle measures, but for the purpose of proving our triangle is congruent, or showing or explaining, really all you need to put is right here. But I do want you to know that the angle measures do not change also. So that is number 30. Pretty easy if you remember the fact that we have reflections as rigid motion transformations. Okay, looking at number 31, it could be kind of tricky. We have to really look at what it says and figure out how to draw a picture that represents what it says. All right, so let's read it together here. It says a flagpole casts a shadow 16.60 meters long. Tim stands at a distance of 12.45 meters from the base of the flagpole, such that the end of Tim's shadow meets the end of the flagpole's shadow. If Tim is 1.65 meters tall, determine and state the height of the flagpole to the nearest tenth of a meter. All right, there's a lot of stuff going on here. So let's just look at it piece by piece and see if we can figure out what's going on. All right, so it says a flagpole casts a shadow. So we know we have a flagpole. So by definition, we'll just call this a flagpole, and we're assuming it's going to be a 90-degree. That might or may not be something we have to use. So this is our flagpole. It doesn't tell us the height, because that's actually what we're looking for. So we need to actually find that, but this is the flagpole. Okay, now it says Tim stands at a distance of 12.45 meters from the base of the flagpole. All right, so I'm going to just draw Tim here. Okay, so let's imagine this is Tim, and this distance here is 12.45 meters. Then it says, so let's read that again. Tim stands at a distance of 12.45 meters from the base of the flagpole, such that the end of Tim's shadow meets the end of the flagpole's shadow. This is the part that gets confusing. All right. Now, the flagpole shadow, now you have to imagine if I have the sun up here, got the sun, and imagine what happens when the sun comes down. It hits something and you have a shadow that's created. So what it's saying is the shadow that hits the flagpole and the shadow from the person So we know the shadow of the flagpole is 16.6 meters long. So let's write that. Where would that be at? Well, that would be on the ground. Remember, the shadow is always on the ground. So we can say that right there. So this entire distance, this would be our shadow. This is 16.6 meters long. And then it says, such that the end of Tim's shadow meets the end of the flagpole's shadow. All right. So we have, let's see, we're going to do something like this. I don't know if this is drawn to scale. Now, I'm going to take away Tim, and instead of drawing Tim as an actual person, I'm just going to draw him as a line. So we're going to just assume that the line represents Tim that I'm about to draw here. All right, so I'm going to draw a line. All right, so it says that his height is 1.65 meters. So this is 1.65. And so now, what do we have here? We actually have now two similar triangles. If you can see it, we have a triangle, a bigger triangle here, which includes what I'm about to outline in red. We have this. And the length there would be 16.60. And we don't know anything else about that one. Then we have a smaller triangle right here. Now that one would be what I'm about to do in blue here. It would be this. Now we know this piece is 1.65. Do we know anything else? Well, I want to see, can you figure out what X is right there? So I want to take a second and try to figure out what X is. All right, hopefully you took a second to look at this. Hopefully you understand what I did right here. If we know the entire side is 16, and we know this part right here is 12.45, and we know that this side here is just going to be 16.60 minus 12.45, which means that our side here is going to be 4.15. Now we actually have similar triangles. Now we can set up a nice proportion, and it's going to be, now remember, what we're looking for is this. That's what we're ultimately looking for. So what we can do, any number of things we can do here. Let's see, we can do X over 1.65 is equal to 16.60 over 4.15, right? Remember, this is no longer something we're looking for. So remember, on X is what we're looking for over here. All right, so we just solved that. So take a second to solve that. All right, so once you get here, you cross multiply, and we have that. So we have 4.15x is equal to, there's my calculator here, 27.39. And then you just divide both sides by 4.15, divide by 4.15, and you end up with x is equal to approximately 6.6 meters. Approximately 6.6 meters is our answer. All right. You also could have, instead of the proportion I set up, you could have actually set this up. So notice the difference. You could have set up x over 16.60. So now I'm doing this side to a side in its own triangle is equal to 1.65 over 4.15. Now, if you notice, you're still going to end up multiplying the same things. You're going to still end up multiplying your 16.6 and your 1.65 just like you did for this one. And your answer would still be 6.6 meters. All right? So check that out. If you see any mistakes, let me know. All right, let's look at problem 32. As you notice at the top, this is the first problem worth 4 points. So be careful and write down everything that you can, because I want you to get all the points that you can on this problem. All right, so let's look at it. It says in the diagram below, EF intersects AB. So EF, remember, talking about this line right here, so that's EF. Intersects AB and CD. So AB is obviously going to be this one here, CD is this one, at G. So they intersect at G, respectively, and GI is drawn, so GI, that's this one, is drawn such that GH is congruent to IH. So that might be important. So we know that GH is congruent to IH. So those two sides are congruent. That's not something they mark for you. That's something that you need to just know. All right. Now at the bottom it says, if the measure of angle EGB, so where's EGB? That's going to be, remember, you start at the letter and go from the letter down to the other letter. So that means this is 50 degrees. 50 degrees. All right, that's 50 degrees. And measure of angle DIG is 115. So that means this one right here is 115 degrees. Explain why AB is parallel to CD. Why is AB parallel to CD? So they're telling you that it is. They're not asking you if it is. Right? Remember that this means parallel. That's a simple thing that students forget, and if you don't remember that, you have no chance to do this problem. So it says explain why they are parallel. So what would make two lines parallel? Well, think about for a second, and I'll be right back. All right, let's just go through and see what we can figure out based on our knowledge here. Maybe we can find some missing angles. And if we can show that the alternate exterior angles are congruent, or the alternate interior angles are congruent, or the corresponding angles, if you have two lines and you have a line going through called a transversal, if you can find that, for instance, these two angles are congruent, alternate exterior, excuse me, if you can show that these are congruent, you know that these have to be parallel lines. Or if you can show that the alternate interior angles are congruent, that means you have parallel lines. So there are a number of different ways we can go. So let's just get all the information we can and make sure and explain. We want to explain. So we can say that angle GIH is 65 degrees because it is a linear pair with, hopefully you see it, what's it a linear pair with? GID, with angle GID. And you can say linear pairs are supplementary. That means adds up to 180. So supplementary. And 180 minus 115 is equal to 65 degrees. All right, so we have that part. So we know that this is 65 degrees. All right, so that's something else we know. Now, if you look, we also can see that we have a triangle here. So triangle HGI, which appears to be what type of triangle? Well, hopefully, if you label it correctly, you have these lines, which means two of the sides are congruent. We don't know about the third side, but if two sides are congruent, we know that it is an isosceles triangle. So we can actually say that triangle HGI is isosceles. I think that's right. All right, is isosceles, which means the base angles are congruent, which means that the base angles are congruent. All right, so the base angles are congruent. And that would, what are our base angles? Well, we know, remember, it's always the sides, whatever sides are congruent, the opposite angles are congruent. So we know this side, the opposite angle is this one, then this side, the opposite angle is going to be this one. So we know that angle HGI is also 65 degrees. That means angle HGI is 65 degrees. All right? So we just found that this is 65. Degrees. All right. And as long as we're at it, we can get the fact of, we can get the angle GHI, right? GHI. We haven't gotten that one, right? GHI. So GHI, we know that the triangle is 180 degrees. So if two of the angles are 65, then this must be what? Remember, 180 degrees in a triangle. So you have two angles that measure 65 each. That means that we have 180 minus 65 plus 65. So it's 180 minus 130. So that is 50. That means that angle HGI, is equal to 50 degrees by, well, let's say, because interior angles of a triangle, interior angles of a triangle add up to 180 degrees. And if we know that's 50, we know that's 50 degrees. We know now that there are two corresponding angles that are both 50 degrees. So what are the two corresponding angles? I'm going to erase some of this stuff now and just look at our corresponding angles. So we just found that this angle is 50 and this angle is 50. So if you can try to imagine this line and this line and then this line going through, since the corresponding angles are both 50 degrees, that means these lines AB and CB have to be parallel. So since EGB, so let's write something else here. And there might be a quicker way to do this. I'm sure that there is actually. But this is one way you could do it. And you might as well write as much as you can. Just, get all the points you can. All right, so since angles Let's see, let's go back up here. EGB, and GHI are both 50 degrees. AB, line AB, pass, well, let's write something else first. Are both 50 degrees and corresponding AB is parallel to CD. All right, there we go. So that's actually a lot. There's probably a quicker way to do it. But whenever I do these problems, I like to just go through and see what I know about the diagram. And, you know, you might as well write it down as you're finding the information. Just in case you can't actually get to an answer, the more you write down, the better when you go through these types of diagrams. Okay? So that's the that's numbers 30 through 32. If you have any questions on that, or if you think I made a mistake somewhere, which is entirely possible, just let me know.